You have parallel rows of chondrocytes with thick collagen fibers. So they're going to appear in pad-like cartilage of the knees as well as the intervertebral discs. Okay? When we start talking about the growth of cartilage, you have two forms. Appositional growth, and this is the growth from the outside. So the layer of the chondrocytes in the pericardium builds outward new cartilage from the external face of the cartilage. Interstitial growth is growth from within. The chondrocytes inside of the cartilage divide. They lay out new cartilage matrix. So the cartilage expands from within. Usually cartilage will stop growing during adolescence. But because that's when you're really also having the skeleton stop growing. Now, some cartilage will have calcium salts deposited within the extracellular matrix. This occurs during normal bone growth, but also occurs during aging. But this does not change cartilage by definition into bone. Bone has a different cell type and tissue arrangement altogether. So let's start talking about the classification of bones. You already did some of this in the lab. We have the axial skeleton, that's the long axis consisting of the skull, vertebrae column, and the rib cage, okay? Now, the appendicular skeleton, oh, and by the way, remember that that's going to also include the hyoid bone that's up in the, up above the trachea, so it's in the larynx, and it's also going to include the sternum, okay? The appendicular skeleton, consists of the upper and lower limb bones and the girdle. So what I mean by the girdle is, for example, you have the clavicle, and you got what you would call the shoulder blade bone, the scapula, as well as those bones that consist of the upper arm and lower arm and hand. With the hip bones, these are the hip bones that are separate from the sacrum, which is the fused vertebrae. And these hip bones have attachments to, of course, the bones that consist of the upper and lower legs, as well as the ankles and feet. Okay? Now, keep in mind that bones are considered organs. They're made up of several different tissues. They have blood vessels, they have connective tissue, they've got nervous tissue, etc. Keep in mind also that there are different varying bone types. You have long bones, such as the humerus. The bones are longer than they're wider. They usually consist of a shaft and two ends. All bones in the limbs, except the patella, wrist, and ankle bones, are long bones. Short bones are roughly cube-shaped. Examples are the wrist and ankle bones. You have also the sesamoid bones, and they're shaped like a sesame seed. They vary in size and number in individuals, so really you can't count them as the overall number of bones that exist in the average human body. But small bones that exist within a tendon, they function to alter direction of pull of the tendon. For example, I have one that's in my proximal part of my finger, my index finger, the good index finger, and I can feel it from time to time. If I irritate it too much, then it starts to hurt. But it's embedded away from the actual joint into the tendons that control the flexing and extension of the finger. From there, let's move to flat bones. These are thin, flattened, and many are curved. For example, what you're going to find are in the shoulder bone, the scapula, the sternum, the breastbone, the ribs, and most of the skull bones, okay? And you've dealt with that before. Now, you've got, of course, the irregular bones. And the irregular bones are irregularly shaped. Examples are the vertebrae and the hip bones. I hope that helps. Now, what is the function of bones? I mean, what do they do? Well, they support the body. Yeah. They also provide a cradle for soft organs. They also provide some protection for organs, which we'll get into in a minute. If you look at the lower limbs, they support the body trunk. The ribs will support the thoracic wall. For protection, if you think about it, the skull, protects the brain. It also protects, in a lesser degree, some of the sensory organs, such as the eyes, because you have the orbits. But the best known protection is, of course, heart and lungs, which would be the rib cage, the ribs, and of course, then the spinal cord, which is basically inside of the vertebrae. What about movement? Well, yeah, I mean, muscles do the contracting, but they're going to use the bones as levers for movement of the body and body parts. The design of the joints determines the range of movement. We're going to get into later on a chapter, I believe, on joints subsequently. So don't worry, we'll get there soon enough. I believe that's chapter 8. Mineral storage. Here's an interesting thing. The bone serves as a reservoir for calcium and phosphorus. Now, withdrawals and deposits sounds like a bank, but in a way, think about it like a bank. You have deposits of these minerals occurring constantly. As you are growing, most of the situation is you're depositing the calcium and phosphorus into the bones. As you get into adulthood, you're going to have this dynamic exchange of some calcium ions and phosphate ions are pulled out of the bone, and while others are being redeposited in. As we get older, it's going to be more calcium and phosphate taken out, okay? But the interesting thing is that you will have times of greater deposits, particularly for limbs, and I'll show you this in a little while, depending on if those limbs undergo a lot of stress and strain, exercise, running, athletic events, pitching, playing tennis, the tennis arm. Also, the thing is that if individuals have calcium shortages, okay, in their diet, etc., what happens is to maintain the calcium blood levels, the cells in the bone will begin to break down some of the bone tissue to basically resupply the calcium ions necessary in the blood. Finally, we have blood cell formation. And the majority of the blood cell formation occurs in marrow. Marrow is usually located in the center of the bones. There are two types, red marrow, yellow marrow. Red marrow is actively producing. Next time you go out and you have chicken and you got it like a chicken bone, you break it, you see that there's this reddish stuff in the middle. It's not gross. That's marrow. Okay? And that's where it occurs, and particularly in all the long bones that you see, but in some of the other bones as well. The yellow marrow looks a little bit like chicken fat, but by hormonal signals can be revved up and converted to red for the purpose, let's say that there's a greater demand for red blood cell production, things like that. Okay, let's start talking about bone gross anatomy. Now, the external layer of most bones is going to be compact bone, while the internal layer is spongy bone. Spongy bone consists of having also a lot of open spaces, and in those open spaces, there's going to be marrow located. Compact bone is a dense layer that looks smooth and solid to the naked eye. We'll get into that, and you're going to see also that when you see your tissues, there'll be a slide for a ground area, what's called ground bone, and you're going to be seeing basically compact bone with all the different pits or structures that allow for the formation, for the passage of blood vessels, as well as the sites where osteocytes, bone-making cells, exist. When you look at the spongy bone, it's really a honeycomb of plates and needles of bone. And this is called the trabeculae, with open spaces present. When you look at the long bone, we're going to take a look at that for a minute. It's tubular, or the shaft of the long bone is referred to as the diathesis. It has a thick collar of compact bone for structural support, as well as a hollow central medullary cavity. This is the cavity where you're going to find marrow present. The epiphyses are the boned ends, okay? In many cases, they're more expanded in width than the diameter of the diaphyses. Ends that usually have covering of compact bone, and especially in joints, have further covering of an articular cartilage. Now, this articular cartilage is really a cushioning, so that opposing ends of bones during joint movement don't basically have bone crashing against bone. It's sort of a protection. It's also used to absorb stress. As for membranes that exist in the bone, you have the periosteum, and this is on the exterior of the bones, except on joint surfaces. You don't want to have that there. This is a whitish, double-layered membrane. The outer fibrous layer is made up of dense, irregular connective tissue. So think about it. It's got a lot of tissue there. The dense irregular is to withstand pulls, pushes, etc., rubbing, other tissue against the bone, etc. It's all protective. The inner layer, which is in direct contact or abutting the bone surface, consists of bone-forming cells, osteoblasts, and bone-destroying cells, osteoclasts. You also are going to find that you're going to have nerve fibers, lymphatic vessels, and blood vessels present. You have what is called the nutriens foramen. Now remember, foramen is a term for opening, okay? The nutriens foramen is an opening in the bone where blood vessels will enter to supply nutrients to the bone tissue. Now, if you notice there on the section C of that image, you've got this, what they call perforating fibers. They're also referred to as Sharpie's fibers. And that's pointing to what looks like long white fibers. These are really tufts of collagen fibers, and they secure the periosteum to the bone. They're very dense at tendon and ligament attachment sites to the bone. So it's basically they allow for an anchoring right into the bone tissue, okay, into the hard bone. That's where you would have attachments for things like a tendon, which tendons are going to be attachments for muscle to bone. Ligaments are basically attachments that attach bone to bone, okay? So I want you to get that down. Now, the endosteum is the inner membrane layer, which covers the tuberculi of the spongy bone and the central canal of the compact bone. Okay? Now, by the way, also, when you have the structure of something like short, irregular, flat bones, what do you got? What you're going to see is compact bone on the exterior. Now, if we take a look at this section here of the skull, you got compact bone on the inside, compact bone on the outside, but in the center, you're going to have this very spongy bone interior that's also referred to as diploid, okay? And as I mentioned to you before, marrow. Marrow is red, actively producing blood cells. Yellow is inactive. It's held in reserve, looks like a fatty deposit, and can be activated by hormone signals, converts to red for increased red blood cell production. Let me go back here for a second for bone cells, because you really need to get this down. When we talk about osteogenic cells, think about it like Genesis, okay? These are primitive stem cells. They're going to give rise to osteoblasts. Then, osteoblasts. These are bone-forming cells. So B blasts build. Osteoblast has a B, and it's going to build. They form, they're bone-forming cells. They're going to synthesize the bone matrix, okay? Osteocyte is a mature bone cell that maintains the bone matrix. And then we have osteoclasts. Now, osteoclasts are bone reabsorbing cells. If you notice there's a lot of structure inside there. The osteoclasts are going to be very, very active in producing certain enzymes that will dissolve not merely the calcium and phosphate mineral, but it will dissolve the collagen fibers that are sandwiched in between all of those minerals that basically provide also strength. And when you break all that down, that's how you can reshape or reform bones, okay? Now, we're going to start talking about the bone microanatomy. This is particularly focused on the compact bone, but you really need to get review this, okay? Compact bone, as you see here, we have what we call osteons. This is part of the Haversian system. You have